of bonsai, right? Buongiorno, tutto bene? For me, wiring is the language of bonsai. Every time we do a workshop or we have to work on a tree, we need to know how to put the wire on the tree to be able to be very, very precise, and then be able to put all the branches in the position as we want. Either if we style a tree like this, either if we have to do a big bend, we need to know if we want to wire clockwise or counterclockwise. Either if we want to wire branches single from a tree, that we have to know these I have to start here or there. Okay, so if we are able to just schematize the rules, the basic rules of wiring, can be useful for everyone. So, Thorsten, which one is the first rule I have to know about wiring? When
I'm normally wire from the middle of the wire, and also
this is
from,
one of the
from
rules, but the first
lower
one, let's
to
imagine.
top.
Okay, we are here with this tree,
The
and there is
the thickest one.
exactly. We have all the wire. We need to be able to understand which thickness of the wire we have to pick, because otherwise we can overwire a branch and it's dangerous, or we can put a wire that is too thin and is unuseful. Okay? So the first rule is size. Okay? As I said yesterday, the two types of wire that we use is aluminum or copper, right? So we need to have a proportion to use one or the other. And because we said that copper is stronger than aluminum, we can use a smaller size of copper compared to the same aluminum to bend the branch. So let's make an example. If I have to bend this branch and I use aluminum, I will need probably a 4 of aluminum. When for the same branch, maybe I need a 3 of copper, because obviously stronger. So the proportion is 1/3 for aluminum and 1/4 for copper. If I have to design the proportion, this is my branch, this is my wire, this is my 1, and this is my 3. So the area, radius per radius, blah, 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 blah. Engineer, right? The other proportion is easy. This is the branch. I have to imagine 3 pieces of wire inside my branch, okay? And the empty space is the 4th. Actually, this area is 1.2 the area of this, so it's a little bit bigger than the other size of wire, because this geometrical form is called arbello, that comes from the Venetian windows.
Okay.
Can I show off a little bit? So, this is the first rule, okay? Now, second rule. When we approach on a tree, we need to know that we have to wire from the lower branches up, or if we don't need wire in the main structure, we need to know that we have to wire from the inner branches out. Why this? Because we need to build a structure. It's like an electric circuit where every wire has to be touched with another one. If you look at the tree that I worked at yesterday, and you start looking at the big wire coming out, then you restart with the smaller and smaller and smaller, but every wire is connected. So if we keep in mind that this is my tree, okay, so we start from the lower branch and we wire up to another one, okay, so let's say A with B, and then we wire C with D. we already feel that we create a system, okay? And the main trunk is my anchor. Easy. I never do the mistake that if I have 4 branches, I wire these 2 together and these 2 together, because I'm not using the anchor. Same story, if I don't need to wire the main structure and I have a branch, so this is my trunk, and the branch has side branches, always the same rule, inside, outside. So I start with this one, I wire with this one, and then I start with this one, and I wire with this one. So I create my connection. Very, very easy. Sorry, I have to snooze. Unfortunately. This you can cut from the video, of course. Okay? Third rule is how we wire. We have to remember 2 easy words. As before, we was remembering bottom to top and inside, outside. We have to remember 2 other words. One is step and one is angle. If this is my branch, when I wire, I have to make steps that are all the same. So A equal to A. Okay, and the angle has always to be between 45 and 60 degrees. Easy. Why? Because, as I said yesterday, when we push a branch in a direction, the wire is working 90 degrees according to the main angle that the wire is on the branch. So the best angle is this one to push the branch according to the wire. From this rule, we can go to the other one. I have 2 branches. That is what I told you. Think if you need clockwise or counterclockwise the wire here, and the same in the other pair. So you can always wire a branch clockwise with another one counterclockwise. Because you remember that yesterday, this is what Thorsten told, we have a piece of wire that has 2 ends and that has to go in 2 single branches. So we have our U anchor that can be up or down according if I want to go counterclockwise with clockwise or counterclockwise with clockwise. These are the only 4 positions. And that became this rule. So if a branch is wired counterclockwise, these branches get moved from this side because the 90-degree angle pushed the branch left. If the branch is wired clockwise, I'm pushing the branch in the other direction. So clockwise, counterclockwise. Easy. There is nothing more that you have to know about wiring. So if I take an example, probably this is too small, you need a bigger gauge, but I just want to show you. So if I have to wire these 2 branches, and I know that these ones need to be wired clockwise and this one need to be wired counterclockwise. I start from the lower branch. I make my anchor. Okay? I go to the branch clockwise. Okay, then I go up. And I go on this one counterclockwise. So, on this easy piece of wire, we see already all the rules. Size, lower, upper, so bottom to top, bottom, top. We see the U, and we see that one part is clockwise, and the other part is counterclockwise. Easy.
So the top branch you can bend
So
forward now?
this one can go in this direction, because if you look at the branch, let me take this, the 90 degrees is here. So it's pushing here. It will never obviously push back, because this is coming back, but it's pushing always outside.
Forward.
This is pushing inside against the trunk. So this is the part that is pushing. So if I have to do this, and the same here, the 90 degrees is pushing in this direction. Easy.
One question, Mauro. One thing we have been taught also is to watch out if you plan to lower.
I don't believe on that rule. Why? I explain.
Okay, you understand what I mean? Yeah.
Sure, absolutely, I know that. Yeah, a lot of people tell that if you have to push this branch down, you need to start here.
Yeah.
Wrong. Because if I start on top of the branch, look what happened. I have to do this, and I'm wiring clockwise on clockwise. No good.
Yeah.
This angle is poor.
Yeah. But
Is,
maybe the
is,
reason is just that you don't get stuck in between the branch and the trunk there, but I guess it's easy to make.
Yeah, but look how efficient is
Yeah.
this anchor and this one, where the wire from this point is perfectly in contact with the big the trunk, and the same here. But and the purpose is that when I push here, I need that my tension is going, thanks to the wire, back and anchor in a strong part. If I have a weak anchor that can be I hate that branch. So if my anchor is not the U, but is like this, okay? Now my wire is only touching the branch here, and I'm not able to move the tension in the angle like that. And again, we go against what we said, because we are wiring clockwise on clockwise. So, for example, let's imagine.
Can I hold this?
Yeah, you can.
Because you hate it.
So let's imagine that when I have, now we look what's happened on a branch, for example. So we go up, and then this branch obviously divide in little branches. So now we are moving to the other rule, that is branch inside outside, right? So this is my branch. So how is my rule? Inside, outside, right? So this wire is clockwise or counterclockwise? Is counterclockwise. So this has to be clockwise. Clockwise on counterclockwise, and the U is underneath. Always the same rule, and you never miss. It's like with the computer, everything is reconduct to 1, 0, 1, 0, blah, blah, blah. And with wiring is the same. And then you go over. Then I have this branch here, but otherwise this is alone, so I can decide, I can wire this one, okay, and then I need to wire this one single, but better, because if I have to wire this one single, I have to start with the straight line. Better if I do this. I follow the main line, and I go up here. Then when I have to wire this one, I reuse the same rule. Inside, outside, and I use this part of the trunk just to anchor. And we have still, this is counterclockwise on clockwise, again the same rule, clockwise on counterclockwise, and I have my U that is on top. So every wire is on its branch, and when I move this is not moving. When I move this is not moving, and all my tension is here, and from here go back to the trunk. Easy.
Do you think you also sometimes prune the branches so that they sort of fit the recipe?
No,
Like
actually, okay. If I have, let's say, a branch like this that is very dense, obviously is not so linear like this rule. But as I said, we have always to try to reconduct complicate thing on easy thing. And the way is just starting from the basic. For example, when I have the main wire here, the next step is wiring this with this, because those are the two biggest ones. So my system A will be divided in B and C. I did a schedule for you. So, how many order of ramification you see on this sketch? Good. So we have 3 order of ramification, right? So this means to wire this branch, we need 3 size of wire. It's easy, no? So we have the main branch that we say, okay, we need a number 3. Then we have this one, we need a number 2, and then we have this one with another one, right? So we come from the trunk, and we have the first wire, right? So this is number 3. Then inside, outside, I have other, let's say 1, 2, 3, 4, 5 branches, right? That are for number 2. So inside, outside. So I follow the main wire, I reconnect, I go up, and maybe I go here. So this is number 2. Okay? Then I do the same here, and I have number 2 here with this one, for example, because I have a spiral, so I can connect these two together, right? Now my system that I call A is divided in 1, 2, 3, and 4 subsystems, B, C, D, and E, right? Now it's only a question to use this one to wire inside, outside the little one. Easy. So if I take this branch, okay, I do just some cleaning so you can understand. Okay, so this can be easily the same branch, right? How many order of ramification we have? We have 1, we have 2, we have 3, and in this case we have 4. So I know that I have to use 4 wire. The first one coming here, following the main line, to here. Then inside, outside, I can wire this guy with this one, and this one with this one. When I have the wire here, that obviously has to arrive a little bit further here to make my anchor, I can inside, outside wire this with this end. And so it will be divided again. And then here, I wire only the small one, and here only the small one. Easy. So, if this is my 3, this is my 2, and this is my 1, okay, the wire number 3 is only touching the wire number 2. Never go to the number 1, because if I wire, let's say, this guy with this guy is wrong, because they belong to 2 different systems. I have always to stay in the same system. As before I was staying here to wire the number 2. When the number 2 are gone, they make new system. So the number 3 are staying only in their own system. So I don't risk to have too much wire, and especially I don't risk to have too much wire on the main branches, because if from this guy I try to wire like this, what's the purpose to have another wire doing the same road of this one if I already have this one that make his work to move the 2 main branches? I have just to move the small one. So I stay here, and then I stay here. Easy. Any question?
I have one. When do you decide if you want to use a 45-degree angle and 60-degree
No,
angle?
I said it's between 45. Obviously,
Yeah,
when
it just
wire,
happens.
let's say, I'm sorry I'm wasting a lot of your wire, but I know you are a rich engineer, so you can. So let's imagine that this branch has already a main wire on, okay? So I'm starting inside, outside, and wire the other one. So when I wire, the main rule is that I always have to be in front of the branch that I'm wiring, because as I said yesterday, my arm is working like this. So I pull the wire outside. So when I do the angle, let's say here, obviously I have to try to follow a little bit the movement that the branch has, so that my angle can change a little bit. That's the reason I said this part can be 60 then you have a 45, then you have a 50.
Okay.
But is between, because obviously designing something is easy, but in reality, nature is not so perfect as we decide on a board. So we need to be a little bit elastic. You know. The important thing is you don't do angle like
Yeah.
90 degrees and you create a spring, you see?
Yeah.
Or you make angle to open. Even more. Like this, otherwise the wire is not working, you see?
Yeah.
And another comment I got about that is that it also depends if you use copper and aluminium, because copper is stronger and you can have a bigger
A
angle.
little bit bigger angle, sure, obviously, but always we need to take in consideration that we have to have a basic rules. It's like yesterday about the John Naka book. If no one told us that exists the why you are unwiring? Ah, because it's too small.
Yeah.
Cut it. So,
Rule number 4.
if no one told us that there is the Shokan, there is the inclinate, there is a Kangai, everything is too free, and then when we make a tree, it would be a mess if we don't have basic rules. That's the reason I'm trying to schematize basic rule that then obviously a branch is not so perfect as I said. So for example, here everything is coming from the same spot. It would be difficult to have a spiral in between to be able. But if we know the basic rule, we have always to try to reconduct this structure to a basic one to be able to do the work. So if you check on my trees, there are also some tricks inside, some smart anchor and this and that. But obviously, the tree is not like a design, is what I said. Okay? Let's go back to work.
Go back to the coal mine.